Hello, today we're going to talk about concurrent forces and why concurrent forces are important. So, concurrent forces are forces where the lines of action of all the forces come together at one point. So, the line of action is the important part of here, and the line of action is simply the line that the force vector is acting along. So if we've got some force vector in our diagram, the line of action is just going to be the line that kind of goes all the way along that force vector. So all of these lines of action need to come together. Because only point forces have a line of action, though, another kind of caveat to this is going to be that only point forces can be concurrent. If you've got distributed forces, then you're not going to be able to say anything about whether those forces are concurrent or not because you don't have a line of action. So, an example of a concurrent force system, a set of forces that are all concurrent, we've got here a traffic light, and it's a little hard to see because the forces are drawn in, but we've got two cables running off like this that are supporting this traffic light. So we've got three forces in this system. We're going to have gravity pulling down, and we're going to have a tension in either direction holding this up. And if we draw in all the lines of action, that's what these dotted lines are, we'll notice that all of these lines of action come together at a single point right here in the middle. So this is going to be a concurrent force system since everything meets at one point right here. An example of a non-concurrent force system is going to be this table. So here we've got just kind of an end table, and we've got a gravity force pulling down in the middle, and then two normal forces holding up either of the legs of the table. So we'll notice that the forces here don't come together at a single point. And even if two of those forces came together at a point, if one of these was not parallel, it still wouldn't be concurrent. We need all three, or however many forces we have, all those lines of action need to come together at a single point for this to be concurrent. So with concurrent force systems, why do we care? Well, because all of the forces act through a single point, there are no moments exerted about this point. So here, if we took the sum of the moments here, the gravity force, remember our moment is going to be the force times the distance, or the perpendicular distance. So the perpendicular distance here is 0, so it would be Fg times 0, and it would be T2, and the distance there is 0, so T2 times 0, and it would be T1 times 0, because that's another 0 distance. Since everything goes to this point, all those d values in our moments are going to be equal to 0. And when that happens, we have no moments. Because essentially our moment equation is just going to say sum of moments equals 0, but all the moments are 0 in the first place, so my moment equation ends up stating that 0 is equal to 0, which is true, but not particularly helpful. So, normally we have two equilibrium equations. We can say sum of forces equals 0, and sum of moments equals 0, but as we stated before, that moment equation is going to say 0 equals 0. So with concurrent force systems, it actually gets a little bit easier, because usually we can just concentrate on the sum of the forces equation. So we can do sum of forces in the x, sum of forces in the y, sum of the forces in the z. We don't have to worry about the moments. So we can essentially treat this as a particle, and in particle analysis we only deal with forces, we don't deal with moments. So there are no real particles, but the approximation of concurrent force systems as particles is going to be what really constitutes particle analysis. So with that, we only deal with forces. If we're dealing with any of the moments, then we're dealing with something that is not a concurrent force system. So that's all I have for concurrent forces. Thanks for watching, and I hope to see you again.